Hi, this is Abdulaziz Khan, and I am assuming that you have been to my first video and you have finished it. So, as uh, these first three parts were parts of the first video, so like we have seen these three things, and now we are over here. So this thing we need to start. So we have seen that what is DevOps and what are the soft qualities of a DevOps engineer. So now we will try to see that what kind of technical knowledge should a DevOps engineer possess. And one thing that I mentioned in that as well, that here in this second part, I will briefly mention things because my third part, it may be not in a single video, two, three videos, but my third part will have some small demos of everything so that you don't just know things by name, you really know them. So I want you to have some good idea of the tools. And in this video, I will just give you a brief about the tools because the people who have some knowledge of some existing tools, for example, if there is someone who knows some of the tools, then he should know that okay, he has this much of foundation already. So how much more he needs to learn. So I will try to make it easy and better for you. So let's start. So technical knowledge of a DevOps engineer. What is required in you? What is required in terms of technical things? So what is required not in terms of soft things because that we have already uh, mentioned. So if we start, this picture has got some of the tools which most of the DevOps engineers they have at least some good idea. And if you see this DevOps cycle, you will see that the cycle is basically consisting of many parts that we discussed in the first video as well. Now each part has some tools associated, like for example this Puppet Chef, Ansible, Salt Stack. They are a kind of similar things. They are not very much different things. They are in a way, I mean, no tools are exactly similar. Like Puppet and Chef, they work mostly hand in hand. Uh, Ansible, I mean, it can do work of these both. But the thing to tell is that these tools, um each of these tools, they give you some kind of ease in deployment. They are infrastructure as a service tools. I mean, when you put something on Puppet or Chef or Ansible, with the help of this, you can automate the configuration and management of your servers, the infrastructure that on which your uh, payload should be running. So, configuration management, whether you do it with Ansible or Chef or Puppet or Salt Stack or anything else, like for example, AWS has its own tools. AWS tools are quite similar to Puppet and Chef, but I mean they take Puppet and Chef as the foundation, but AWS has its own tools, like Azure has its own tools. Uh, so that's the thing that we have to learn is that what exactly you need, what kind of information or what you should know this tool in a way that you know two, three things about the tool at least. First, you know a small difference I mean, why Puppet and Chef are two different tools? I mean, why it's not a single tool? Why Ansible is only one tool? I mean, which, as I said, that this is considered to be equivalent to both of these. So, I mean, what are those reasons? So, that's why whenever you are um, planning something or you are working on some project, you can give some idea that, okay, in your opinion, this thing can be done in this way. If we have, when there you have of something which is done by one tool or which is done by two tools, then in some scenarios having a single tool is better, but in some scenarios having two tools is also better. Maybe you need only a smaller part of the whole, and you really need the smaller tool, not you really need only one tool. You don't need two tools. Maybe Ansible is a bit of overkill for you. I mean, you need something which is done more easily in Chef alone. So you don't need Puppet with Chef, and you can do it with alone with Chef. So these kind of things you should have some idea. These ideas can even come by reading as well. You can have some kind of reading. I will give you a demo of these tools, so you can do just some kind of demos, and you can learn about the tools, that how much easy the tool is, or how is the tool run. I mean, so this kind of information you need for almost all the tool or most of the tools. I mean, you should have run almost these all of these tools at least once in your life, so that you have some idea whenever you give any interview, or whenever you are sitting with some colleagues or somewhere, then you can um talk to them with a better confidence. So let's get back to our main point. So in this slide, what the main point is that configuration management is something that a DevOps engineer should know. The tools are of secondary importance. You can know any tool, but you should know that what is configuration management, how it is done, why it is done, why we need it, what kind of tools are there, and how those tools generally do these kind of things. So after configuration management, we have continuous integration, continuous deployment. So this is, you can say that this is the main core of the DevOps. This is some, like, for even when I was not in DevOps, I mean, at that time, I also used to think that the CI/CD is the only thing that a DevOps engineer has to do. And this is, we can say that, yeah, this is one of the most important thing, but not the only thing. So CI/CD is, like the name says, is continuous integration, continuous deployment. So it means that this deploy is also part of it, and then this build and test and release, because integration is not a single task. But yes, like some, like Jenkins can do, um, it can be used to do some part of it. I mean, your Git is also getting to involve in most of these parts. So um, a DevOps engineer should be increasing his knowledge with time. So like we mentioned here, Jenkins and GitLab and Circle C. So if there is any new tool coming, or if there is any old tool, or if there is some tool that you can manage it somehow, if you can do some kind of one of the big tasks that we say that every DevOps engineer, he should be very good in scripting, because sometimes you came to know that you have a tool and it can do almost everything that you need, but you need to do a small level of scripting, then it will become better. You will not need two tools. So you should have know some kind of scripting to automate some part of things, to make the things easy for your company. We always, we don't have to go with the best or the very, you can say that very high valued or very highly used kind of solution. Sometimes we are in a position where we need to squeeze in between. We need to do our job with very less resources. Nowadays, whenever I am talking to someone, to my friends or anywhere, I have seen that resource management has become a very, very big task. I mean, um, most of the companies now they don't want you to just invest in a new tool for every new situation. They want you to innovate and use whatever you have in the fullest to you. So CI/CD may have many tools, even the names are written here or not. And these tools basically they automate the build, test, deployment process. So your build, your test, your deployment. This all is part of your CI/CD pipeline. And this can be achieved with one tool or more than one tools. And a DevOps guy should have a very good idea that what is CI/CD and how it is done, why it is done, and what kind of benefits it should bring. When we will go in detail of each of these tools in a small demo, I will try to give you some more these kind of details in that in what scenario we try to go with what kind of solution. So let's go to the next um, containerization tools. So this containerization basically comes after deployment or is it's a kind of part of deployment. Because when you are deploying in deployment your app or your what we called as payload and your infra they are now going to interact with each other. Your app is going to be deployed on that infra in some way. So the best of those ways are Docker or Kubernetes. So both have their plus and minuses. Both have very strong foundation. Docker is very old. Docker is based on Linux containers, and Kubernetes is built on Docker. Uh, I hope I'm not wrong when I'm saying that, but if some of you disagree with it, then you can comment and we can discuss it in a beautiful kind of discussion. So basically, when you deploy an app, there is only one app. I mean, the app code is only one. I mean, you have one image of your code, but based on the load and based on your or based on your geographic location. For example, if you have some kind of app from which you are covering the whole universe and you have to deploy it at least on three places because you don't want your users to have a lot of latency. I mean, if you just deploy it in only one part of the world, and everyone has to reach to that part of the world. So sometimes your load is not too much, but you want to be near to your users. So in that case, you deploy it on two, three regions. Sometimes you want to have it as a high available kind of app, and sometimes you have a lot of users. So all these scenarios they require to have multiple of infrastructure, at least two, three infras to hold your same image. So your same image is deployed in one VM in one region, in another VM in another region to make it highly available or to make it easy or near to the customer. Or sometimes if there is a lot of load, a lot of people are trying to access your app, then in that case, you want to scale it out. So in all those cases, Your image may be deployed on tens or hundreds or sometimes thousands of machines. So just assume that you have a single image, and now that image has to be deployed in the same way, exactly same image and same everything is needed on 1000 different VMs. So in those cases, things like Docker or Kubernetes, they come to help you. Like Docker Swarm is a way in which a Docker image is sent to a lot of machines, and then they are all synchronized because they have to be synchronized as well. Just running it on 100 machines is not enough. I mean, you need to know that how those machines are behaving, which machine is healthy, which is not healthy, if the user requests are being distributed or not. There are a lot of more things. I mean, when you will go in details of these two, then at that time I will try to introduce you to some more things. So like in Kubernetes, we can have the scale up and scale down type of things. So based on the load, we can enhance the number of infrastructure there on which we are um, running our app. So basically, these tools enable us to package and deploy applications in lightweight portable containers, making it easier to manage and scale applications. So next part is infrastructure as code. So infrastructure as code is something which in a way helps you to define infrastructure in terms of lines of code. So previously we in the start we have a configuration management. So infrastructure as a code, as the name kind of suggests as well, infrastructure as a code makes it easy for you that you code your infrastructure or you put your infrastructure in form of a lines of code. Now just assume again, like for example, if you have to deploy a lot of apps on a lot of machines. So now the apps are coming through um, a pipeline, and that pipeline makes an image and prepares the image, and then the image is ready now. But now because we need a lot of uh, lot of infrastructure or machines, I mean, so that on which we can deploy these apps. So if those machines are also controlled by some kind of code, if I can make it easy to configure those machines or make it easy to um, build those machines. I mean, if for example, I have I'm deploying an image in three regions, but I want a slightly different kind of machines in all three regions, and I can um, put this also in my code. So again, when we will go in the details of these tools, so the most famous tools are like Terraform. Terraform has become a kind of industry standard for deployment of infrastructure as a code. I mean, in through Terraform, you can do deployment on all the cloud providers like AWS or Azure or Google, and you can use it for your in premises places also. And not only like cloud infrastructure, you can use Terraform for many kind of infrastructure automation. So when we will be looking in detail in Terraform, we will see this. So CloudFormation is a AWS owned tool that is also used for in managing infrastructure, and the great thing it gives is a consistency and scalability. Like for example, if you have a VM and if you make it through CloudFormation or Terraform or anything, so the good thing is that how many copies you make out of it, every copy should remain always the same. And if you have put some kind of if for example you have two, three flavors that you want to change because of some parameters, so you can parameterize these things and you can make necessary changes which are done on the fly. I mean, based on some parameters or some logic or something. One question that should be coming to someone's mind that, I mean, what is the difference between infrastructure as a code and the configuration management tools? So just remember that infrastructure itself and the configuration within the infrastructure, they are a kind of two different things. So that's why we have to use both of them. I mean, for example, Terraform is not a competitor to Puppet or Chef or Ansible or these kind of things. They are a kind of competitor as well. I mean, in some way, because everyone is expanding as well. So Terraform may be trying to expand in these places, or they will be trying to expand in these places. But still, up till now, they have their separate positions. I mean, you can use them. They are strong in some area, so you can use them separately, and you can leverage the best of all. So when I will be going in some detail of the demo of these tools, at that time I will try to show you that why Terraform is different from Ansible. I mean, in what ways these are different. So we will try to go through these small points, but these are a kind of a learning, or I mean a question for the listener as well, that he should also keep himself abreast that basically what is the difference between these. He should know it and he should try to learn it. So after infrastructure and code, we need to go to the next, and this is monitoring and logging. Here, if we see this, so for example, you code, plan, build, test, deploy something, and start operating it. Now you need a kind of monitoring, because monitoring gives you or your developer or your operations guy and inside that what is going on. I mean, if there is something wrong or if everything is going fine, and if something is happening, then basically what is the reason why something is happening in that way. So these are some kind of questions which are answered by the logs and events. So whenever something happens, an event is generated or a log is generated. There's a small difference between an event and a log, um, which again, I mean, we will see that in detail. So, but to make a kind of full scenario, I mean, that what was going on, we have to track all of these. We have to track the events, the logs, and other performance things. And then most of these monitoring tools, like we have mentioned some of these here, like Splunk, which is a good tool, or Datadog, which is not mentioned, but it's also one of the good tools. So the good thing in those tools is that they can correlate. I mean, you are having thousands of responses, you are getting a lot of data. So you need a kind of correlation between all of these so that you can have a best insight that what exactly was going on when something happened. So to know and to get on those values, we need to have a very strong monitoring and logging tool. And a DevOps guy, a DevOps engineer, basically he should have a very good idea that when he should use Prometheus and when he should use, for example, Kibana, or when he should use Splunk or Datadog, and which of these are good for logging, which of these are good for having events only, and which can be best in troubleshooting. So, and especially based on your own scenarios. As I told you that everything is not good for everyone. I mean, having the most costliest or the most biggest or the most powerful tool is also sometimes not the best option for you, because everything has its pros and cons. Sometimes you have the best tool, but just assume if you don't have the best team to handle those best tools, then the tool alone cannot do anything. And if sometimes if you have the best team but the tools are very bad, then even the best team may not be working very well with those tools. And sometimes, for example, your requirement is not that high. I mean, you are managing something which is not of a very large scale, or its performance requirements are quite low. Then even on those times, you don't need to spend a lot or use a lot of bigger things. So, but as discussed in previous things as well, that you have to have a good idea of these tools and in what scenarios they are used, what is good and bad on them. So let's go to the next. So the next is our version control system, or Git. So there is only one name here because Git is a very big name. There are other tools, but Git is, you can say that it's almost monopolized most of the things. Now they have Git Enterprise Server edition as well. They have Git Enterprise Cloud. They have GitHub for everyone. I mean, any one of you, I will suggest that if you want to work in DevOps, if even if you have some kind of, if you feel that it should be good for you, or if you like it, still start from Git. I mean, have an account on Git. It don't cost anything. Get yourself familiarized with Git. You will have a lot of things also to read. I mean, Git has a lot of information, a lot of data, a lot of everything. So, Git is the most famous version control system. It's part of here code. Your code is generally, most of the organization, when you will talk to them, their code should be on Git. So Git has, I think, most of the code of, I will try to get this number. I think it should be a very big number. I mean, that Git has, I can say that more than 90% of the code is available on Git. So basically, Git a versioning system. Whenever you make a change in your code, the change is versioned through Git, and it makes your version control and collaboration, it make it very easy. You can, for example, you can put your code in Git, and then you can connect it through some build mechanism. And for example, these build things, they get the code from Git, and then they put it on any of your repo. That repo will, maybe you can go back to Git as well, but that repo may be your on-prem or whatever. I mean, this we will try to discuss some actual scenarios, some how this all, how it is actually deployed in a working environment. So we will see that what kind of options are there. Sometimes you put the code here, but after building, you put it, the image goes to somewhere else. So it gives you a kind of high availability as well. I mean that if that somewhere else part is lost, still you have your code, so you can build it again. So there are many reasons and many things, I mean, on how you do it. But generally, whenever you think about the code, code is either in someone's local disk, because some people they want to keep all of their code with them, but when their disk crashes, then they are in a big problem. But otherwise, most of the people they have their code on Git. And Git is secure. I mean, you can have it protected as well. So there are ways to do things. I mean, Git is not always public. I mean, you can make it private as well. So let's go to the next. So next is, I mean, like if I just take you for a while. So basically, we need configuration management. Then we need to know continuous integration, continuous deployment. Then we need to know some containerization, some infrastructure as code, monitoring and logging, version control system. And when all of these comes, your code is fully prepared and maintained and versionized, and monitoring and logging is enabled on the deployment, then you need to deploy it somewhere. So you need some cloud platforms. Those cloud platforms help you help you make it easy to manage. I mean, for example, just assume that if you have two servers at your home, and by some way, I mean, in a night, if you become very popular and everyone is looking for you, then I mean, it's very simple to say that those two servers should fail. I mean, if everyone in the world starts looking for you, then the two servers at your home cannot do it. So you need some kind of platform where you have a big trust that even if you became a sensation in a fortnight or in a night or in a day or in a fraction of second, even it can try to go with you. Like I have seen, I mean, we sometimes we scale from one machine to 200 machines. So just assume that for a small company, even having 200 machines is not something easy and simple. And for example, we are managing many different apps. I mean, so if even only two or three of our apps, if they scale out to 100 and 200 machines, then this become a very heavy load. So you have to rely on some kind of cloud partner so that they can help you in your managing your applications and finalizing a cloud partner is not very easy. I mean, there are a lot of reasons. We will go in detail of it a bit, but still that detail should not be enough because this is more of a financial decision than any other decision. Because at the end of the day, uh, even that is right in all of these as well, but here the costs are a bit different. So at the end of the day, it comes to the money that you have to pay from your pocket. So all of these are good. They have their um, market capturing. I mean, they have their market shares. AWS, Azure, they have very high share. GCP has a bit lower share, but still they have significant share of the market. These three, they make, I think, more than 70% of the total market of the whole world. So from this you can understand, but these two are big. This is a rather smaller to these, but they are big companies. You have to learn each of them separately. I mean, you have to have some idea of all of these. We will give a demo on all of these one by one, but I would like you to encourage you to engage with all of these. You can very easily and freely, by freely I means in free in terms of costing as well. I mean, you can test all of these. It will not cost you even anything almost. And you can even test them, use them, you can know them, what is good and bad, and you can learn about them. So I think it was a good journey for you guys. We have just touched some names. We have not gone in the details. I have even not taken all the names which are written here. But when I will go in the demo section, I will try to give you a demo of most of these. Like for example, Ansible, Chef, Puppet, Git, Jira, and then Jenkins and Splunk. And even from here as well, I will try to give you a demo of almost all of these so that you have some idea. And the time that you have spent here is good for you. I mean, you should learn something out of this time. So I hope that you understood something. I will kind of encourage you to that if you are with me, if you are following me, if you have reached up to here, and still if you have some queries in your mind, then don't stop. I mean, you can WhatsApp me, you can email me. I usually reply within 72 hours. I don't take, mostly I reply within 24 hours, but as it is a kind of, I mean, there is no SLA on me. I mean, because I am giving a kind of service, so that service has a larger SLA. I mean, for me, it's sometimes it's not easy to reply instantly, but I try to reply everyone. This is a kind of my quality. It's not like that I reply to a few guys and I don't reply to. It's almost never. I mean, I reply to everyone who contacts me, and because when you guys ask any question, that becomes a very good thing for me. I mean, from that question, I myself I learn new things. I get some idea that okay, people are talking about this thing. So I sometimes those things are new for me as well. Then I have to do some research. I have to work on that. Then I come back to you with most of the time with a new video so that you can then see and everyone else can also get some idea of that new thing. So I hope I have been talking enough. Uh, so we have if we go back to this agenda for a while, then we have gone to this part. But before my final, I mean, video, which will be about the kind of demos, let me, because I'm a kind of, you can say that I have missed this part, which I will not be missing. So let's just delve into it for just for a while, not for long. So DevSecOps. Okay, this should be a good thing to end my discussion as well. So DevOps is now not um, alone because this also I will try to, I mean, in everything I'm saying you, when I will be giving a demo, I will try to give you some details at that time because security has become very much crucial nowadays. If you see some of the videos on YouTube made by BBC or some other companies which are of public interest, I mean, they will show you that how much insecure you are as an individual, as a company, as a family. But it does not mean that you should remain like that or you should think that it's your fate to be insecure and someone should must uh, steal something from you. No, it's not like that. We are insecure, but we are always securing ourselves. So even for the DevOps, we have a DevSecOps. So development, security. So we don't have a development and operations. We have development, security, and operations. Security has come in the middle, not it is in the middle to separate these. Basically, if you see from this picture, I mean, basically security is now covering or trying to safeguard DevOps. So now from here you will understand why it is like you have the dev here, the ops here, and the sec is all around. So because they cannot put sec all around it, so they put it in between of it. So you have dev, you have sec, and you have ops. But basically the security is trying to save you from any kind of mischievement, and it's trying to protect you from everywhere. So we have the same chain of DevOps, but that chain is under a fully monitored and secure guidance of the security. A kind of word that you will learn if you will be in the DevOps regime is a shift left strategy, which everyone is talking right now. So if you remember that we have in development we have a kind of uh, generally we follow uh, from a start we follow a kind of a phased approach, like we plan something. Here we have made it a kind of chain, but if you cut it from here and you make it long, so we plan, when we create, verify, we produce, configure. So we start from planning. Even in the DevOps cycle, uh, it will always we will say that we start from planning. We don't end on planning. So we start on planning and then we write some code or test some code and send it to production and configure our infrastructure based on it. Then we start detecting problems in it and responding to it, and then we predict the growth and other things, and we adapt to the changes. So even though this adapt after adaptation, we again go to planning, but as I told you, the plan is something from where we start. So the term shift left is initially what was happening was that for security we were mostly concerned in this area, which is in the operations, because we thought that this is a production system and it is the users can access it, so it's more prone to the security. So security was basically maintained in a crucial way in this area, I mean. But now we are shifting because this is almost the end of the chain. From here, this chain restarts, I mean. So, and in a normal, I will try to add this that kind of picture. I mean that we put plan here. Let me kind of draw it. So like we plan and then we code and then we test and then we deploy and then whatever comes after that, I mean operations. There may be different names. These names are, but if you see, this is on the left and then these are on the right. The security was kind of implemented initially in this area. We were more concerned because we thought that this is the area where our customer and everyone. But now we came to know that the intruders or the perpetrators or the bad guys, I mean, they are even trying to know what is going on here. They are even trying to make something here. Because they know the vulnerabilities are here as well. So that's why we are shifting this security to the left. So this is called shift left strategy. So by DevSecOps, another very, very common name is shift. My handwriting is very bad. Shift left. So this is shift left, that you implement your security in the very start of the cycle. So DevSecOps is also a very nice and very good thing to learn, and we will talk about it as well. So it's good that I remembered this, and we take some time though for it as well. So we have finished our agenda, and now you can say that we are almost done for the theoretical part of it. So there are some final tips and takeaways. Uh, Number one is that learn by doing things. This this will be my key thing in my last and the third and the last video, where I will be providing you the demos of most of things that we have gone through. So we'll go in demos. And in during the demos, I will tell you how you can find resources, how you can find free resources, because I'm not I'm not against spending on learning, but or even though I'm for spending, I mean you should, what I believe is that if you don't spend, I mean you cannot learn well. You should spend, but before spending there should be a time, I mean, when you should be ready. I mean that you should know something, that okay, if I'm going to spend, I mean I'm going to spend on what? So to reach up to that place, you can use a lot of free resources. There are free resources, there are free training, there are free certificates as well. So I have given it another measure the depth before diving. I mean, you want to dive in a pool, you should ask someone that, or you should try to guess, or you should try to know, or you should try to research that how much deep it is. So you should spend some time on free resources before going for a paid option. So paid option is a must for, I mean, what I feel. I mean, I may be wrong, but I mean, I personally feel that this paid option is a must. But which paid option, what you should read to reach to this paid option, you should spend some time here so that you don't make a wrong decision, and you don't spend a lot, because I'm basically making it for the countries where or the students, because students have some limitation of, I mean, if you're working for some big company, you already have a lot of resources, I mean, but if you're a student, then you should not uh, spend without understanding, I mean. Then uh, one point is timing and transition. Sometimes uh, even myself or anyone, we will agree that sometimes people say that this is a good time for this is a good time for that, or sometimes people say that no, 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 now you cannot transition, you have spent a lot of time here, you spend a lot of time there. So I will give my own example here. Maybe everyone should not fully uh, understand it, or maybe it Um, I mean, like for example, someone can even laugh on it or whatever. I mean, that's not any problem. But like I'm almost reaching 50 years of age now, and I was a pure telecom engineer. For me, this IT and these kind of things, these were kind of magic words, or these are very unknown words. I mean, whenever someone told me DevOps and CI/CD or these kind of things. It was something which was far beyond my imagination. And this I'm telling you just 2, 3 years ago. I mean, not 10, 15 years ago type of. I mean, even reaching the age of almost 50, and within 2 or 3 years, I made a decision and I switched from one field to another field, and I learned. I will not say that I fully unlearned because experience is something that I feel that it gives you some foundation, some value. But I had to unlearn a lot of other things, like I had to unlearn the way of working and how to approach people and how to do a lot of things, because the telecom, especially in Pakistan and our area where it is not in a very good shape now, it has a lot of administration issues as well. So, but I never thought that it is something that is either impossible or I should not do it. It's not the time. I have 25 years of experience of something behind me. I mean, I just have to let it go and I have to start from zero. I mean, at the age of, I mean, some people they even retire at this age, and at the age of retirement, I am trying to learn something very, very new. But these things did not stop me. So, based on my personal experience, I will try to suggest that if you are also in a similar situation or a better situation or a worse situation, if you have some doubt, you can contact me. And if you have some confidence, then don't be afraid. I mean, just try to uh, take this wagon. Hopefully, it will not make things difficult for you. So, practice makes your experience. When I was going to give my first interview somewhere, this was a very big question for me that when I will be giving any interview anywhere, they will ask me that, okay, I mean, you are a good guy, I mean, and you have a lot of experience of something else. But I mean, what experience you have in this field? So what I did is that I did a lot of labs. I did a lot of labs on Google and AWS, and I take the dashboards and I worked on them. I make VMs and I delete VMs and I do many, many things which I could do. So I had a lot of idea. I mean, when I gave an interview, I was quite confident and I told them that yes, I have never worked in an actual organization, which is fine. I will not uh, I was not of the opinion like just joking, or I mean some people they what they do is that they try to fake as well. I mean faking is I think it should never be an option for a professional. But uh, I will just discuss it because it's a kind of social dilemma. Sometimes what happens is that we become very afraid and we say that if we try to tell everything truth and plain, then maybe people will not accept it, which is of kind of right as well. But still, I will say that you should not be afraid. I mean, if you have worked on labs, if you have done some kind of certifications, if you have some good idea, then you should try yourself. And hopefully, everyone has a place for him. So you can have experience without job, and that experience is actual experience. Like for example, if you open an account on AWS, it's a free account for 1 year, and that is exactly the same account that I have from my company. I mean, there's not a difference of what we call it, there's not an iota of difference between the two accounts. So it's not that they are giving you something else, they are giving you some trial kind of things when you are taking it as a trial version. No, they are giving you exactly the same thing which they are giving to their multi-million dollar customers as well. So you can have experience without a job and you can work on actual things and labs and environments. And I will give you some demo of it as well. So Now, my takeaways is always keep learning, communicate with people. This is, I mean, this what I can say. This is the only thing which can even, this alone can take you very high. Take feedbacks from people about you. That when you give an interview, or if when you meet someone, or when you meet someone twice, just ask him that what is his idea about you, and reflect on yourself as well. Some sit for a while and think that what you are doing. Explore new things. This you have to done by force as well, but better to make it your habit. Set personal goals, even though I'm not very good in it, but yes, it does not mean that this is something, it's very important. Iterate and adapt. So iteration is required. I mean, even the DevOps is a chain. It iterates itself. So you also have to iterate it. But like we work mostly in a agile fashion, so I will guide you, or I will suggest you to be agile in your life as well. Because as I told you, I have a lot of experience. I mean, I started from a government sector, a job which was very, very rigid. So my starting is from a rigid place. But with the passage of time, I learned that if you adapt, if you are agile, if you are always ready to change, then the things they become much more easy for you. If you are always ready for change, if you come to a place tomorrow and they say that uh, you come to a place and they say you come to a new place tomorrow, then don't say that, oh, a new place, how I will adjust, or how I, no, you just go to the new place and just adapt yourself. So always be ready for a change environment, a change thing, a change in plan, a change in everything. The day of today, I mean, the things are run today in the similar way. I mean, it has to be very fast and very, very challenging. So I hope we have really finished it this time. Not like the previous two times, I mean, that I finished it and then I add something in between. So I hope if you have reached up till here with me, so you will be ready to dive into the demonstration of the things that we have mentioned. So in the description of this video, you will find the link of the next and the previous videos. So in the description, I have the link of all the videos. So you can go to the next video now, and I will try to give you demo of most of the things which will be easy for me. And if you need to have some idea of something, then don't ever hesitate to contact me and keep in touch. Like we say here, communicate, communicate, communicate. This is a solution of all the problems. So see you. Goodbye. See you again somewhere. Okay, fine.